So we'll be our presenter. Senthil will be taking us through this session. And then following from Senthil, we have Hui, who's here in Singapore. He'll be taking us through IoT and MuleSoft, so a bit of a demo around here and some technology to look at on that side of things. And then to finish up, so we have some, I guess, generally look to do some news around what's also been happening in, I guess, in the MuleSoft world, and we've got a few updates around that side and a bit of a quiz and brain tease, and then we'll wrap up thereafter. For those of you joining for the first time for Singapore, so again, welcome. Just to introduce myself quickly, so my name is Julian Douch. I'm a senior director at Capgemini. I'm based in Singapore. Was formerly part of the White Sky Labs team, which was acquired this time last year by Capgemini, and ultimately looking to help customers and with their, I guess, their transformational programs and challenges and leveraging the MuleSoft technology along the way. For myself, been really involved in probably integrations for a good part of my career, so that's 20 plus years now. And so kind of seeing all the various evolutions of various integration technologies, and so can see how everything's evolved today and where we are today, and the new challenges that are upon us and that we help our clients with. So that's really me. If you do have any questions, please do reach out. Happy to always provide a point of view around both integration as a whole and MuleSoft similarly. With me today also, so I'm going to introduce Royston, who's a bit new to the Singapore meetup. Royston, do you want to give yourself an introduction?
Sure. Good afternoon, good morning, good evening, wherever you're joining. Hello, this is Royston Lobo. I work as a senior technical architect in the customer success team at MuleSoft. So I've had the privilege of being at MuleSoft for 2.5 years, and I've spent almost all of that time in Sydney. So I started in June 2018, and in my role in customer success, I got more and more involved with the meetup community in Sydney, as well as the online meetup. However, in January this year, I decided that I wanted to make life a little more interesting and relocate to Singapore. And so I'm now part of Singapore in the Singapore MuleSoft team. And it means that I'm better equipped to contribute to the Singapore meetup community as well. So looking forward to making this meetup very valuable for all of you, and hopefully in due course meeting you all in person as well. So thank you all for having me. And looking forward to some good times in the future.
Okay, thanks. Some good to have you on board, and I think from having maybe watched you and followed you from afar, very much an evangelizer in the MuleSoft community, and so if anybody is looking to get connected, you can both leverage myself, but probably more so also Royston. Very, very enthusiastic and well respected within the MuleSoft community, both on MuleSoft itself and also in the wider customer space. So do reach out to either of us if in the future if you have any needs or wants, or like Royston already said, if looking to present, and I'll come on to that later in the presentation. We're good to have other people share your thoughts and experiences. Okay, so without further ado, so our first presentation, which is going to be presented by Senthil, also from MuleSoft, and we provide an introduction to Kafka and integration with MuleSoft. So Senthil, over to you.
Okay, thanks, Julian. Thanks for this opportunity. Okay, so good evening, everyone, and good morning, good afternoon, like wherever you are. Okay, and my name is Senthilkumar. I'm part of like professional services MuleSoft in Singapore. So I've been with this MuleSoft for close to 1 year now, and I've been in this integration stacks for a while, more than 12 years. I work with the different product stacks. And of course, today I'm going to share about that my experience and my knowledge towards Kafka and of course, how Mule integration with Kafka. And before I jump into that detail, I just to give a background that today is in integration space. And when we talk about integration, definitely messaging platform plays a major role in a different context. Maybe we consider that the application to application data exchange in a decoupled manner. Sometimes we say broadcasting, like means that one-to-many relationship basis, and when the data is get exchanged. And we consider always messaging systems, and we come across so many messaging platforms in the market. Of course, I'm not going to compare anything here. Like basically, I just going to share Kafka is one of the component which stands ahead, and people generally talk about that. It's an open source and then comes with quite a few features in it, and say that okay, we going to leverage Kafka as a messaging platform. Right. So I just want to bring you through a small session and PowerPoint presentation, and to connect with what is Kafka all about. And Kafka, when you talk about messaging platform, what is it architecture all about, and what are the different use cases Kafka can be used, or in a high level, I can touch point on that, and followed last but not least, and importantly, when you talk about integration with MuleSoft. When you say MuleSoft integrations, of course, we have quite a few things there. I will touch point on that because that will be the value added in terms of MuleSoft ALC pattern, ALC, I would say, approach along with that Kafka connector and so on. Okay, and maybe I can share my screen. And okay, I hope you can able to see my screen.
Yes.
Yes, thanks, Julian. Yeah. Yeah, so basically, just to move ahead in that, what is the agenda for today's discussions, and I mean today's sessions in another 20 to 30 minutes time. It's basically giving a Kafka overview and use cases of Kafka and Mule integration. As I just mentioned right now, I jump into that Kafka overview aspect of it. What is Kafka? When you talk about that, open source and RabbitMQ and AMQ, quite a few things are in place. And what is it Kafka stands for? So Kafka is open source, of course, we know that, and it's a distributed, publish and subscribe durable messaging platform to exchange data between the applications. When you talk about Kafka as a kind of infrastructure or as a kind of system, it consists of so many components in it. And it's like you can see this picture that there is a producer, a consumer, and top of that, as a standalone Kafka alone comes up with a lot of interdependent components in that. Why do we say Kafka? Like sometimes when you choose that options, like what are the options I can consider to choose for Kafka? And one of the important things always, like it says that stand ahead is that commit log architecture, which is basically gives that fault tolerance in a distributed platforms. And also, and we can say that it's basically the throughput or like performance wise like a better compared to the other players in the same ground. Okay, let me jump down to that individual components in that. When you talk about Kafka in a Kafka cluster, and it's combination of multiple broker instances. Broker is a common word we hear upon in across like any messaging platform. You take same way we say broker as a kind of instance. In the same way here, Kafka server instance is called as a broker. So across the broker clustering, and broker are stateless component, means that it doesn't have any information which is get stored in that broker in terms of like a clustering aspect of it. And that's where the zookeeper plays a role in terms of saying that zookeeper and coordinate that within the cluster and making sure that who is the leader, who is the follower, and so on. And also just like any new broker coming into the cluster or leaves the cluster, or any topic coming in or leave, created newly to that, within broker, or just like removed from the broker. All those informations are coordinated by the zookeeper. And Kafka comes out like when you talk about broker, broker is literally is a storage. And the message comes in, message is stored, and somebody push it, somebody's pull it. And Kafka comes with the 4 API stack. One is the producer API, consumer API, streaming API, and the connected API. So APIs are nothing but it's a libraries which somebody can implement that and take that library to implement their own in the product stack. The same way here in the producer API, basically the producer is the one which they push the message to the topic. When you talk about topic, within the topic, it's like topic divided into multiple partitions. That's a value-added proposition in the Kafka standpoint. When you come into the topic, it's like you want to scale out a number of partitions, and then the partition can be scaled out towards multiple brokers. It means a replica. That's why it says that distributed system and ensures that the fault tolerance is taken care. So the producer aspect of it is push the message to that broker and the particular topic, and then it get replicated. They have a feature called in-sync replica, ISR. And before the producer pushes the message to the respective topic, and it has to identify only the leader the producer can connect for. And that's why it just connect to the zookeeper, because it coordinates the cluster. The zookeeper provides the information about who is the leader, so that like the producer just connect to the leader and then push the message to them. The other side is that consumer. Once the message is there in the partition, the consumer pull the message. And the Kafka is like the push from the producer side, the pull from the consumer side. It means that consumer is not coupled with the Kafka architecture. Consumer is a it's like it's a pull. It means that it has its own control of how to manage things in terms of scalability, all those things. And that's one of the value-added advantage, because it's not tightly bundled together. And again, like every message coming into that topic, the topic is nothing but you can assume that it's just like in general we talk about queue or topic, the same mechanism here. The topic, there is no queue here, it's a topic. Within the topic, it's broken down into multiple partitions. Each partition is something called, you can consider as a file, log. Log basically like first in, first out. That is sequential message coming, and the message get committed, and then once the message is committed, that the consumer can pull that message. And the zookeeper, every message coming in, it basically has a unique number. That's called an offset. And the consumer, it basically like based on that, whenever it read the message, it commit back saying that that's an offset, it's committed. It means subsequently any communication happens, any consumer try to connect to the same topic and partition, it goes with this updated one, not the same way. Like otherwise, unless it's a broadcasting. So you can see a picture here. It just talk about that there is a leader and the replica. So it means that when the publisher, that is the producer, when the published message happens, and it has a control on that based on the performance tuning, it can say that whether the commit to only on the leader level or it's all in sync. So it has a configurable parameters rule. I will provide more detail on that. So this is a high level one, and this is the same thing. We just put it here. And the important parameters are it's a topic, and the partitions, and then replica. These are the three things which plays a major role when we talk about Kafka architecture. And what are the use case we think of? These three things are like handled in a different way. It means a number of partition to be created from the throughput standpoint, and number of broker to be there in a fault tolerance aspect of it. And of course, topics according to that, how many topics you want, and so that the producer or type of messages can be stored. Right. The next comes, of course, different use cases. And when you talk about, okay, it's a storage, it's a messaging platform. But when you talk about, I would say, use cases, why there are different use cases that Kafka can fit in. So before I jump into that, the use case, which is the integration of Mule with Kafka, so I just want to elaborate the possible use cases. The messaging use cases are predominantly used in a Kafka as a messaging platform. And why is that so? Because compared to that, other messaging systems, the Kafka provides a better throughput, and it's a distributed, and so and another thing is a fault tolerance, because it ensures that the message is guaranteed because it's persisted across the different broker. And keeping all those parameters well suits for, like I would say, a large scale messaging processing systems or processing application. Okay, that's where we can see a lot of comparison between the RabbitMQ, what it can do, what Kafka can provide. And according to that, that messaging layer can be chosen upon. The next is the metrics. When you talk about metrics, it's purely kind of a monitoring aspect of it, monitoring the operational data. So when you talk about monitoring the operational data, it basically requirement is that it's a consolidate and different applications or different distributed system data, and then just kind of like a centralized way so that the monitoring can work on it. The same way here, the Kafka is used in different two aspects of Kafka feature. It's used for the metrics. One is it allows different distributed across applications can hook into that and push the message. And also the storage capabilities allows you to store for longer duration. Typically, the any platforms messaging side, we talk about TTL, time to live. The message is always bound with a few milliseconds or seconds or minutes and the days. But whereas Kafka is a pure storage mechanism, it allows you in even month and years, the retention period of the message. So as long as the message is there, consolidation happens there in a centralized place, and the monitoring is allows you to extract the information to display it as a monitoring. And the another use case, which is a website activity tracking, which is basically to understand the traffic happening in that website, or to evaluate that what's the consumers or the users most demanding options are there in the website, which are things that are improved much better. So these are the data required, but especially website activity tracking, it's a volume of messages quite high. And another thing is that, and of course, like latency, low latency, all those aspects, and the Kafka can be used in that stand. And when you talk about log aggregation, so log aggregation, there are tools like Strives and Firms, and all those tools are available. It's a standalone tools which is dedicated for that. But there are cases where the user prefer a log aggregation solution as a Kafka. The reason being is that basically log aggregation happens is that it just takes the log files from different systems, put it in a central location for the processing. When you put a Kafka in coming place, it just basically abstract out all the log file needed. And then it gives the aggregations in terms of like a distributed system, different sources can hook in, and then it provide the messaging. So it's a low latency, and of course, like the fault tolerance allows that way. Streaming process. Streaming is the one basically like we talk about that. Kafka provides one of the APIs called streaming API. When you talk about streaming, it's a pipeline of action to be taken place, because the data which is coming in, and there are a very good example is that credit card fault tolerance identifications or troubleshooting, those kind of identification part means that the data is coming in on a random basis. There is a kind of shuffling and then identify that, filtering the data which is relevant for the final one algorithm which to apply for. So the streaming API, basically the Kafka which provides, it basically provides one layer, and it allows a certain operation to certain process to take place. For example, like you can say some kind of consolidation, some enrichment of the data to avoid duplication of events which are part of consolidated information, so on. So the streaming API pull the message from the list of topics, and then does this kind of operations or pre-processing, and then push it back to another set of topics, so that the subsequent system can work on that particular processing layer, rather redoing all those aggregation, all those things. And event sourcing, and which is very predominantly like messaging, very, very important, that aspect. It's called event-driven architecture, EDA. When you talk about EDAs, of course, like we can relate to a lot of scenarios we can put in. EDA place, that's where like async API coming in place, and async API with the different channels, and Mule is embarking to the async API in the future roadmap. So the event-driven architecture, basically the application which is designed, which trigger whenever the state change happens, it's immediately that events are locked into kind of like time-based logging, means a timely sequence is required. So the Kafka provides a solid, I would say that a distributed storage mechanism, and it helps for the application as a backend layer where to have those events be persistent, and it get broadcasted to the quite a range of sources, distributed application to acknowledge that or act on that. Okay, and the last but not least, a commit log use case. And when you talk about commit log, it's very important that this is one of the feature and ensures that the fault tolerance is absolutely taken care. The persistency, reliability of the message are taken care. And across the brokers in the cluster of, I would say the Kafka, and across the broker, there is always a commit. The mechanism of storage is same like a log file. Okay, but in log files, it's always the commit ensures that the guarantee of the messages. So we actually in one of the use cases, which I'm going to touch point, and there we use the two use cases here, one from the messaging use case and then commit log use case put together. We accomplished and some of the scenarios in one of the, I would say, telecom provider or touch point on it. These are the high level I can say. Of course, when you have you want to drill down more in information, of course, you can just go to that Apache Kafka websites. It has a more granular aspect of it. And another important thing is that the Kafka configuration is very easier in terms of like just keeping the properties. I would say that in say it's there is a kind of a producer properties and consumer properties. That's all. So put all those properties, whatever it required, it basically work on that in a very straightforward. Okay, let me move into that. What is that use case which I'm talking about? This is a very important thing where Mule integration with the Kafka, I would say. And recently we have implemented a scenario where for a telecom provider, the use case goes like this, and they have a order management system basically exposed to the customer, or like customer provides a different request to the systems in terms of like changing their value-added services and their account details, payment information, etc., etc. So the only constraint then the customer wants to ensure that the message coming in the same order, the message get to be committed in the downstream application. So this scenario accomplished, and with a combination of Mule, ALC, like API lead connectivity approach, along with the Kafka and some of the features in the Kafka, right? So that's where you can see here, like there's a process API, and then it push it to the topic, and there's a Kafka connector, which is basically extensively all the properties whatever required from the producer standpoint, consumer standpoints, can put together to accomplish that. Let me dive into more detail. So these are high-level diagrams you can. So Kafka, whenever we talk about message, like when the message comes in, it basically the message contains three parameters is there. That one is basically like I would say key, and the payload and the header. Key and header are optional. I mean, some cases it's used, some cases it may not be, right? So when you talk about that, the producer in generally and outside, I mean, any other messaging, traditional messaging platform ensures that the sequence of messaging till the producer's side, because if there be a queue where the message coming in, it says that, okay, I'm done. So producer side, so the messaging sequence is taken care. But quite a few challenges happens in the consumer side, where the consumer, it's always we want scalability. We want concurrency. A lot of things we put in their thoughts. Then obviously, when you go with that individual way, concurrency or scalability standpoint, we may lose the sequence of messages which is stored or which is maintained from the producer side. So whereas here, like there are two features which is Kafka brings in to address that part. And Kafka allows that there is a key, which is any message coming in, there is a key can be populated. If the key is not populated, it means that internally Kafka has an algorithm, round robin algorithm, to identify which partitions it can place it the message. And if you provide the key in that, basically the key is internally Kafka does the hashing mechanism. It identifies the uniqueness from the hashing, and then it chooses the first message, it chooses the partition, any one of the partition, and the subsequent message which is coming in, as long as it is the same value of hash, then it will go to the same partition. It means that even though you have n number of partitions, and at any point in time, the message which is coming from the same customer here in this scenario, it taken care to that sequencing aspect. When it comes to the sequencing in the producer side, is taken care from the consumer side. When you say there's a concept called consumer group. They say that, okay, if you want, you can have consumers as a broadcaster, means that everybody can pull the message where they can consume it. But if you want that any given point in time, only one consumer to act on that particular partition, then it's called a consumer group. It means that you can have in a Mule runtime, you can create a server group or server cluster across active mode. Absolutely, you can do that. But the only one thing you have to make sure that the group ID across the consumer aspect to be unique. When it comes up, like when you deploy the consumer applications, basically the zookeeper identifies that across all this the unique ID, group ID, it formulate the consumer group. From that group, it always makes sure that only one thread act upon to that partition at any given point in time. It means that there is a sequence is taken care from the producer side, and the consumer side, only one act upon into that partition. It means that guarantee of sequence is also ensured here. So these are the two things we taken into the leveraging this particular scenario use case, and we could see that we could fulfill that what the customer expected for. The next is that, of course, you can see this is a pictorial representation of what I explained right now, and there's a unique key to be maintained. And of course, there is an advanced version right now which says that from the performance standpoints, if I say, hey, I don't have a requirement to keep key as a value. I don't have such thing, but key is to be null. But I don't want to be a round robin, because round robin means like it has a lot of IO operation happens upon. It chooses that, it randomly goes upon. Okay, I want just basically take care certain things, then you can do that as well. So there is a a mechanism allows from the producer side, you can batch the messages. You can say, hey, I want to reduce the latency. I don't want so many IO operations to happen. So I can batch it together. I push it into publish in one request. So that batch entire message within the batch goes to the one partition. So that way you can reduce the number of IOs in a disk wise. Right? So and of course, last there are quite a few parameters we indicated, but I conversationally like I indicated the same thing here. Sometime I just want to touch on certain things, and before I just wrap it up, like when you talk about producer, we always say that, hey, I don't want, I have some performance related aspect based on your requirement. What kind of your throughput or latency oriented, or are you more focused on the fault tolerance? Your message is very important. Keep all this, I know all these parameters into consideration and come up with certain thing. I mean, the configuration. When you talk about producer side, you say that, hey, I don't mind, I just want to the producer message number of messages coming in. It should be quite fast enough, the throughput to be increased. So then that basically Kafka allows to do that. The Kafka, when the producer publish a message, either you can do an in-sync replica, or you can say, hey, it's a fire and forget. Or I want to make sure that the leader, one of the replica is good enough for me to, I'd say like a replication point of view. I don't want all the replication to be successful. So which is context related to the throughput. If you want to increase the throughput, you can do that. And also you can do the compression. You say that, hey, end of the day, the messages are stored. I want a longer duration of the storage, the message. So I don't want to, use a bigger storage, and which is I want cost effective. So I can just compress the message in the producer side. In the consumer side, I can decompress it. Yes, absolutely, it's possible to do that. And of course, like you can say that commit wise from the consumer standpoints, like you can do a commit additionally, like Kafka connector, which is off the shelf, comes from the Mule, has so many other options like that. So we have say that operations like seek, commit, and those things will help you to move the offset back and forth. The seek will help you, and then commit will control you, that saying that you don't want to just get the message from the topic and then just say commit, but you want to flow to be completed, or due to some critical process to be completed, and then you manually want to commit that particular offset. You can do that as well. And last one, I just want to highlight that there are cases where you want to reduce the number of network operations. Like from the producer side, it's just like doing IO operation, network IO operations. So you want to reduce that. You can go with the batch size and the buffer memory, and all those things will help you to avoid, I would say, low latency. Low latency in terms of ping pong happens more often. That would be avoided. And these are things, of course, you can elaborate more due to the time constraint. I limit it here. And I give the ground to any questions to ask for. That's all from my side to the sharing. Yeah.
Okay, thanks, Senthil. Very informative. Thank you. Is anybody on the call? If you do have any questions, please do put them into the chat area, which you can access from the menu on the right-hand side. I guess a couple of questions, maybe just from myself, just to kick things off. So I think, as I said, thank you for that. Very informative. I guess one or a few questions I'll go with. So number one, I guess, so in terms of MuleSoft and Kafka, I've had a number of situations where customers have said, oh, well, I've got Kafka, do I need MuleSoft? Would you say MuleSoft is very much a complementary technology on top of Kafka? And what's the value add that you can leverage MuleSoft on top of Kafka? Where do the two really coexist?
Okay, it's a very good question, Julian. And Kafka, it's a standalone if you think about, and just like a PubSub mechanism in messaging. But if it comes to the MuleSoft and the API-led connectivity, the ALC approach, which very much provides a complement, which gives a decouple the API layers, and then the messaging plays an intermediate role. But not just if you go only with the Kafka, Kafka is more as like a bottleneck, that the only source where you put all the messages. Whereas here, what we are doing is that we are not just coupling only the messaging as a backbone for everything. We just still use that kind of stateless API calls, but the messaging is used just like an intermediate messaging. But it's a use case to use case, it differs. And sometimes when say that I want to use it as a log aggregator, of course, I won't say that, the message is still required as a full blown, means that you real storage mechanism. That way, of course, API lead connectivity approach is always fit into that, the decoupling option, which allows not tightly binded with that. At any point in time tomorrow, if there is a replacement to be done from the, let's say, Kafka to be replaced, let's say any other messaging platform coming in, it's easy. It's a plug and play model when you put it together in a Mule ALC with the Kafka.
Very good. Thank you for that. It's a couple of comments, so thank you, Murali, and thanks, Senthil. Very nice session. And then, apologies, as it Boa has asked, Senthil, could you explain just quickly the difference between the topic around topic and difference between topic and partition again?
Yeah, sure. And topic is it's a superset, I can say. Within the topic, we create the partitions. Partitions are, you can say that typically in a traditional messaging system, AMQ or RabbitMQ, you have a queue. That's all. Like you place a message into the queue. But whereas the Kafka says that, okay, I just within the topic, I divide the topic into partitions. So the replication happens from the partition level. That's a value added, and because the replication is not in the topic level, because you put a message, the topic goes off, or due to some reason you can't extract a message from there in a traditional messaging system, it lost. But when you break into the multiple partition, the partition get replicated. Even one partition doesn't properly replicate, the other partition is still on the fly. I hope I addressed that question. Yeah.
Okay. Thank you for that, Senthil. Another question from Murali. So what would be the maximum message size Kafka can handle?
Okay, it's a subjective, because if you go with the batch size, it says 60 KB. See, from the Kafka, it's a pure storage. You assume that it's not a memory place where garbage collection or GC plays a major role. Not at all. It's purely the storage. It means that how big the storage you are going to provide when you do the infrastructure wise. That's one thing. Second thing is any storage comes upon, there is always a caching layer by default comes in. Like you won't, the IO operation doesn't happen directly to the kernel. There is always a caching there. So I would say that it's not, there is no size bounded, but sizes are quite high. Terabytes are handled. And there are cases we have seen that the terabytes messages are handled. There is no predefined size as such. But it's you can treat it as a storage, as a kind of as a constraint for you if you want it. There is no hard sizing for that.
Very good, thank you. Saravana, okay, could you explain in situation group rebalance happens? Just trying to understand, commit cannot be completed from the group or rebalance assigned partitions to another member.
Okay. So the rebalance, okay, so when you say rebalance, basically like the commit, there are cases where it's an in-sync replica, which is the zookeeper maintains that who is the leader, who is the replica. If in case replica doesn't do, due to some reason, there is always a kind of, there's a heartbeat check. Within this particular scenarios, if the replica not come back in a, say that I'm done my part. If replica doesn't give any signal, the particular replica is disconnected. So the in-sync will only with whichever is committed. That is where the rebalance happens. Let's say if a replica is due to any network glitch, it's get disconnected, it's coming back. Then what happens is that the zookeeper understands that, okay, it's coming back to the network. So whichever committed logs are like committed logs in either leader or partition, it makes sure that before it completely commit to that cluster, it sync up first from the partition side, and then it will bring in. That's what they call it as a rebalance. Yeah. I think that's did I understand? I believe that's what I understand. Okay. How does it single turn? Okay, maybe I can just say zookeeper may be the victim of single point failure. Okay. Good. And I would say that every product which comes with, there is a pros and cons. Okay. And why we say zookeeper, it's like, of course, a zookeeper is a lightweight one. It's just to maintain the information. Of course, zookeeper goes off. You can't bring up the server itself. If you really notice that Kafka, when you bring up the server, it will make sure that zookeeper is already running. If zookeeper is not running, the Kafka doesn't come up. Of course, there's a bottleneck there, and It's every product has its own kind of like challenges as well. So I would say I'm not. I just say that make sure that the zookeeper, whatever information is required, the substantial clustering, and of course like active mode, everything is taken care. And the biggest scale of growth, which is there in the Kafka, which is of course zookeeper is a minor part. It takes care of the clustering aspect, but if you give enough clustering aspect of zookeeper, it's well and good.
I think that's quite typical of things around, yeah, exactly, when you got caching strategies, caching technologies, and all of these types of things where you're using multiple instances and distributing traffic and everything for complete resilience and scalability. Then having that zookeeper is always in the same space, and I think that's Kafka is no different in that.
Yeah, Julian, if it is okay, I address the last question, which is
yes. I have one more for you as well, actually.
Yeah.
So, but let's do this one.
Okay, consumer group, how does its singleton consumption enforced? Okay, so basically we don't have a control. That's a mechanism from Kafka itself. The commit log future allows, that's where the in-sync replica, the ESR future, ensures that at any point in time, as long as that you make sure that all the cluster consumers are under one group, it takes care of the singleton aspect. We don't have to configure anything. And it makes sure that only, because if you really notice that the consumer, before it just consumes the message, it takes that offset from the zookeeper. The zookeeper identifies that the group ID. According to that, it will allow whether any other thread is currently acting on the partition. If yes, it doesn't allow, give the offset value to that. So that's a zookeeper, again, plays a major role in terms of identifying, making sure the singleton in terms of consumer group.
Okay, very good. My question to you is really just around that the point of integration between MuleSoft and Kafka. I think I saw you probably using whether in one of the APIs. So is there a standard out of the box Kafka connector, and is that really available on the exchange?
Yes, it's that's I would say plug and play model. Like we have in the exchange, you can browse through that. Kafka connector is there. It's I would say like 4.5.1. It supports the latest version 2.7 Kafka. It has a lot more features, and especially if you are using a Mule runtime 4 series and Kafka connector, so many features are there which allows you batching, buffering, and in a more optimistic way to avoid based on the bandwidth you have. Based on the performance aspect of it, so many parameters are there. It's there off the shelf. You can download it, and it's a plug and play. Yeah.
Very good. So I think with that, Senthil, thank you very much for that presentation, and all of your answers very clear. If anybody does have any further questions, please do feel free to still put them in the message box, and we'll see if we can get them addressed. If not, we can take it offline. But anyway, thank you again, Senthil. Much appreciated for your time.
Yeah, it's my pleasure, Julian. It's my pleasure. It's a thanks to everyone and the organizing committee, giving for me an opportunity to share my thoughts here. Thank you.
Excellent. Thank you very much. So over to you. Have you able to present on your side?
Sure. Let me share my screen.
The next session is Hui, so principal architect at Capgemini, and as I introduced previously, so Hui's going to take you through a bit around the world of IoT and MuleSoft. So Hui, over to you.
All right. So basically, I'm going to present how MuleSoft and IoT are in these presentations. So in the layman term for IoT, basically IoT describe the network of physical objects and things that are embedded with sensors and software that is connecting and exchanging data. So in terms of usage, there's a lot of statistics mentioned that by 2021, this year, there are around 25 billion IoT devices installed around the world from sources are from Forbes and Security Day. And I believe in Asia Pacific alone, the spending on IoT expected to reach around 200 over almost $3 billion US. All right, so it's a very hot topic in terms of IoT usage in the real world implementations. So I'm going to show the IoT trends and how it affect our life, and through the integration with MuleSoft, how we provide the information exchange and integration throughout this 5 area of implementation. So one, we are going to showcase the sort of like show the usage in healthcare, and then we are going to show the usage of IoT in Industrial 4.0. We are going to show in how it is going to affect the retails and the implementation of smart city, and also in finances. Okay, for number one, basically in IoT in healthcare involve a lot of transformation, especially in this COVID pandemic. There is a lot of devices, IoT devices, that are used as a tracker and tracing devices. So and also, there are some IoT implementation for hand sanitizer dispenser. So the other usage, which more prevalent now, is basically the IoT are used for senior generation as a smart devices, what they call the fall detections IoT devices, where it can actually detect whether the elderlies are you also have the real-time heart monitoring IoT device, where it connects back to the hospital or clinics to monitor in real time the heartbeat. There are also health monitoring sensors where it provide a real-time blood glucose monitor. So previously, when there are a lot of patients that uses diabetes test strap to actually test the glucose level. So there are IoT device and smart sensors that can be used, as I showed in the below here, where there are sensors embedded to monitor the blood sugars. There are also implementation for health insurance, particularly in one of the biggest insurance, Manulife, Move, where they actually have a smart app where they actually monitors your health, and also provide sort of like discounts for your premium. So the more healthy you are, then basically they actually provide more discounts for your insurance premium coverage. So it's actually quite prevalent in the healthcare industries. So the other implementation of IoT is on Industrial 4.0, where there's a lot of industrial automation, particularly in terms of robotic, where this robot and the sensors used basically provide data analytics for the management to data analytics and report. There's also a lot of implementation where they actually provide a predictive maintenance for the production line. And basically, most of the IoT device will actually gather data and collate the data in real time to the central control of a manufacturing plant. So one of the implementations that are hotly being used right now is the motorcycle electronic fuel injection and tuner, where the IoT device are basically there's a sensors in a motorcycle engine, where they actually provide this information in real time back to the manufacturer, so they can actually monitor the engine performance for the motorcycle or cars. So it's actually a very intentional topic, and basically it's wide usage in the implementation in automation world. The next area in IoT implementation is in the retail. So basically, the IoT provide a digital shopping experience. For example, the supermarket chain Hema in China, they provide a lot of IoT in terms of info counters, in home delivery system, where all the tracking devices are embedded in the shopping cart. And also, when you check in or check out to the supermarket system, it basically provides facial recognition, where it sends all this data to the servers of the supermarket. And the other area in retail is supply chain automation, where basically they use a lot of robotic delivery system, and these provide this information in real time to track your product and your goods. So in terms of the implementation, where they have also provide IoT in printer sensors for uninterrupted service, and smart shelves detection for products, for perishable goods, so you can actually track the lifespan, and also, so for example, temperature of your product and goods. So the next area for IoT implementation will be in smart city. So for example, in a lot of traffic management, the traffic sensors, the traffic coordinations of the IoT device, where the IoT device sensor actually detect the road management and provide feedback to the traffic controls. There are also a lot of implementation in terms of smart metering, where you can actually monitor the power consumption and usage in your home. There's also implementation in terms of smart waste management, where most of the rubbish bin and the especially on the recycle bin, where the sensors can actually detect the type of waste and the sorting of the recycling materials. So there's in Singapore, I think there is a robot. They already sort of like roll out the robot delivery system, where they actually deliver the groceries and parcels to the residents. So this information, the robots will actually send the information when it arrives at the resident of home, and notify the resident to collect it at below their residence and their lobby. So it is already in the implementation stage now. So the other big area where we have IoT embedded is in area of financial industry. So IoT provide sort of like a multi-channel approach to banking, to P2P payment system, to single banking and self-service banking. So in terms of IoT for banking industry, there's a rollout of ATM 2.0, where it's combination of ATM devices and your smartphone, where you provide an additional layer of authentications in terms of biometric authentication, where we can only provide in key, the PIN, and also biometric authentication to withdraw money, or basically to send payment requests to third party, so for them to able to withdraw money. There's also a lot of IoT payment, especially in the next generation point of sale system, where it's enable user to use their mobile device, interact with IoT payment to make payment at retail stores. There's also a lot of implementation in terms of virtual teller machines, especially for the bank, DBS Bank. The other bank that are rolling out a lot of IoT for their banking system is OCBC, where they actually implement facial recognition ATM, which is the first bank to roll out this ATM 2.0 implementation using open banking API in Southeast Asia. So basically, they can actually provide more security and a step more closer to eliminate the physical ATM cards. All right. So in terms of MuleSoft reference architecture, there is a shift of paradigm where the introductions of a more robust layer, where we have the client. There's sort of like three layers for the IoT reference architecture. So on the first layer, where you can see here on the left side, the client layer is where the IoT device are located. So the IoT device could be a smart sensors, or it could be just a simple sensors within that device that actually collecting the data, the surrounding data, to provide more vital sensor informations. In the middle here, where we have the edge layer, the edge layer basically is a layer that sits near or in a local environment that actually manage all the information, collate and basically filter large amount of data from the IoT devices into a meaningful data that basically we can actually send to the server layer. So the edge layer is basically sort of like a gateway or controller that you can actually apply the standard default policy that can actually translate and filter the information that can be sent. So the server layer is basically the platforms, cloud hub platforms that can provide the API-led kind of connectivity, where it's a typical API-led connectivity architecture that provide experience APIs, process API, and system API. And eventually, you can actually have the server layer process the API to be distributed and propagate to a backend system such as Salesforce or database. Right. So in demo, I'm going to use the use case of food transport. Now, for this, I'll be using the temperature and humidity sensors in Raspberry Pi. And for the client layer, I'm actually using a Raspberry Pi to capture the two information. One is the degree, the temperature, and second is the humidity. Once this my Raspberry Pi sensors capture the information, it will send the information to the edge layer where it actually collate and filter the information. And this edge layer is sitting on the local environment and very near to all the near to my device sensors. So once this information is collected, the edge layer will actually send this information to the server layer so it can be further processed. So one of the use case is you can actually provide automation or robotic or even data analytic reports. Or this information can also be propagated to a SaaS or iPaaS application such as Salesforce. All right. It can also send the information to the central control to monitor the temperature and humidity of the food item here. So the sensors will be located either in the truck or in the fridge storage. The edge layer will actually collate and filter all the data. And this data will be sent over to the server layer where it can actually goes to applied as data analytics reports, or even basically informing the robots or the robotic automation or production line to remote control the temperature or inform the management about the temperature and humidity of the food that is being transported, right? So here I'm actually using a few IoT device sensors here. One is I'm using a humidity and the humidity and temperature sensors where you can actually collect. So I'm also using API. These are Raspberry Pi with together with other sensors, so we provide the information. This is the LCD RGB backlight which I connect to the Raspberry Pi. All right. So this is another sensors device from Raspberry Pi, where this provide a PIR sensor, a motion detector. All right, I'm not using for the demo here. I'm using a temperature and humidity sensors to provide this information. All right, here we go with the demo. So first of all, I'll be starting the sensors here. This is the client layer, where this is where I log into my Raspberry Pi and run the application. So this on the bottom here will be the edge layer, where these are located in the local environment, the same as my Raspberry Pi sensor. So going back to the architecture, the Raspberry Pi sensor will actually send information to my local edge control here, and then basically provide this information to the application that server layer, which is a MuleSoft application in the Cloud Hub, which is actually running in Cloud Hub. And there's the server layer environment control API will actually send the information and update the Salesforce product information. So basically, this information will be in real time. It will capture the information in real time. All right. So this is the runtime manager to provide the logs. So whenever there is a changes of information on the temperature sensor, it will actually capture and send this information to the local environment, where you can see it here. Every time there is a changes in the environment, you can see that it actually send the information. It will collect the temperature and humidity, and then send it to the environment control application to the Cloud Hub, and the Cloud Hub application, MuleSoft Cloud Hub application, will actually send the information to Salesforce. So as you can see that every time I refresh, every time there is a changes of humidity or temperature, the Salesforce will actually capture this information. And once this information is being captured, you can actually drive the implementation from Salesforce, where you can actually use a lot of analytic tools, event or make it into event-driven tools, and then send this information to management as a report, or send this information as an event where the temperature that needs to be controlled and monitored. So every time there will be changes on the humidity and temperature, all this information will be sent over to the local on the edge layer, send it over to the environment control application in Cloud Hub, and then this information is reflected in the Salesforce in real time. All right. So back to you, Dylan.
Okay, very good. Thank you, Hui. It's really, I think it's a very real real topic, if that makes sense, and a very topical topic of the moment. As we especially maybe for those in Singapore and also in where smart cities are definitely becoming more important, smart devices within the home, and I guess the plethora of information which has been generated by these devices and technologies, which are essentially very kind of lightweight in their own right, but the data that's been generated is huge, and bring in that kind of those edge technologies, and making use of that data within the context of an enterprise, and how, you know, decisions and automation and business processes are now hanging off it is really key, and bringing MuleSoft into that mix, I think is really interesting, and definitely something that we'll see more of in the future for sure. Okay. I think you know, and there is some very real stuff in a number of customers that we're working with, talking to, and alike. That are starting to do so. So, yeah, it's really good. Thank you for your efforts. Any questions, anybody, as I move across? Yeah. So, first question. So, thank you. On edge layer, where is it mentioned in Mule? What was the interface used?
Right. So in terms of edge layer, is architectural layer. So basically, edge layer also uses the enterprise version of Mule runtime, meaning that is the typical enterprise Mule application. What it means here is basically you can also use API Manager to manage the edge layer, the Mule application on the edge layer. So in terms of interface use, is basically the same typical enterprise Mule runtime interface, where you can actually use the API HTTP REST interface to interact with the device.
Okay, very good. Last question: is the client posting over a TCP, HTTPS to Mule endpoint?
Yes, it's HTTP for this demo, but you can actually use HTTPS. So basically, you just need to get the certificate installed on the edge layer.
I guess there's also one for consideration, and getting into a bit more of the details we'll go through. But there are a number of, I guess, maybe say proprietary technologies and communication protocols which are native, let's say, to some IoT devices, and I think where Mules, I know there's a number of connectors and ways of connecting with IoT devices. Is that correct?
Mm-hmm. Yes. So in terms of different protocol or different transport protocol, for example, for devices that uses TCP or Bluetooth, normally it actually provide a device gateway where it actually collect that information of TCP and Bluetooth. It becomes a Bluetooth gateway or a TCP gateway, and that in turns sends the typical HTTP REST from the device gateway to the edge layer.
Okay. Royston, any thoughts on your side? Have you seen any IoT stuff in Australia, or your time in
literally posted about it. So I had the privilege of being part of the MuleSoft hackathon last year, and one of the topics was IoT, and I just shared a link in there, and there were a number of examples that came up with IoT and Mule being used together. Not so much in the enterprise connectivity space, and I think the reason for that is that the hackathon was more geared towards consumerism as opposed to enterprise IoT integration. However, you could see the thought process and the creativity that members of the community had. So I remember one of the better videos that was created was Jason, I think, an ambassador. And what he did is he used IoT to monitor the temperature of the room that his kids sleep in. And instead of him having to wake up and respond to his kids feeling too hot or too cold, he used IoT and a method of temperature control to make that aspect of his life easier. So, I mean, it's simple and sometimes feels like silly use cases, but we can see that when we actually think about, and we stretch ourselves and use our imagination to come up with use cases and solve them. We can do it not only for our personal lives, but also for our professional lives as well. I think the real challenge is to be convincing organizations to take that leap and identifying ways to realize either a revenue gain or a cost saving to make it worth it. There's definitely, it's his experience in so many ways. It's, it really can't be described succinctly anymore.
Well, I think I know one of our colleagues in Manila did a similar session on IoT not so long ago, and the instance they used actually was very much in similar to what we presented, I guess, but temperature control. But they very much looked at also predictive maintenance aspect of it, right? And I guess we're looking into the bordering into manufacturing 4.0 and industry 4.0, where you've got intelligent things, I guess, and components. And, they were looking into predictive maintenance aspects. So whether it be air conditioning units or whether it be machinery that you you start to see where machines are reaching a tolerance of their performance, I guess, and being able to then understand that, do ordering and predictive maintenance visits and alike on basically that machinery to make sure that effectively your manufacturing plant in essence remains continuous and your production lines can continue without downtime. And because if you imagine that in warehouses or in manufacturing plants, if you stop production for an hour, that could that's actually an impact on productivity and business. So no, I think that's some really good stuff. And like I say, then bringing that understanding, that data, and using it in enterprise applications, I don't know whether it's Salesforce or SAP or ERP systems, and to do all of that downward ordering or initiating workforce management tasks and the like. I think that's where the business value is, right? And that's material dollars, I guess, that can be easily explained back, and then making sure you can connect those things is where MuleSoft really plays its part.
Julian, I did have a question for Senthil and for Huey. Just curious to get some input on reliability of messaging and connectivity. So I guess from an architectural approach, maybe Senthil, you first, and then Huey. If you have use cases where you're having enterprise IoT and potentially that involves a large amount of transfer of data and messages, what's your approach to the appetite for message loss? Do you see that it needs to be as robust as a financial services institution, or you think that there can be a bit more of a compromise there because of the volume that's coming through?
Okay.
Senthil, you first?
Yeah, okay.
Yeah.
Okay, so when messaging, when we talk about IoT, it's more on I would say streaming the data. It means that it can be data is very important at that point in time, because the first data and the second data, there is a correlation. When you talk about that, there is a unless until if the data pattern is observed, it cannot be like in the final system cannot take the pattern out of it and decide that what could have happened. The IoT is more on that aspect of sampling the data and then decide what's happening and then react. And so it means the messaging platform, messaging in that case is very, very essential to avoid any misconceptual interpretation of it.
Mm-hmm. Right. I think, in my opinion, I mean, it depends on the use case. Like, for example, if you're talking about transporting food, I mean, sort of like there is a large amount of data that's being sent over, and there is sort of a degree of tolerance that you can accept where there is a loss. But it's in terms of like finance, ATM banking. I can't imagine if, let's say, there's a lot of people that doing transaction and you suddenly lost the message. That's where I guess there's Kafka comes in, there's MQ comes in. Where MuleSoft actually provide that utilities and platform in order to propagate and secure and manage that kind of message and information.
Thanks, Ray. Thanks, Senthil.
It's a really good question. From relaying back 22 years when I started and working on WebSphere MQ in banks, the whole precedence around how WebSphere MQ built their whole proposition was around guaranteed or assured. There's always a bit of a message in there, legal messaging on that side of guaranteed delivery of message packets. When we see ourselves here today, and we've got very transient layers, such as MuleSoft, I think there is still that need, for that. In some instances, again, I think you got two great examples we gave, which was somewhere between banking and you need losing a transaction of someone's update into their bank account is not a good thing. But if you have data which is continuously being created and just created and overwritten as time goes, then potentially there's not such an impact for it. But I think it's definitely use case specific for sure. A couple of questions just relating to RPA, and we have touched upon some of those things. I think, so RPA, yes. So the answer is there are examples, there are case studies also around MuleSoft and RPA, and a huge amount of complementary, again, use cases that leverage both technologies. we actually in the last meetup did a session on RPA. So if you look back at must have been back in December now, I think, on the Singapore one, there was we did a presentation. It wasn't using automation anywhere, but another lead-in product. But similarly, it's a similar concept. So if you need any more questions on that, Murali or Diraj as well, we can provide information on that. But yeah, do look back on the previous sessions on the Singapore MuleSoft event page, and you can see that there's also very good documentation on the MuleSoft website as well around some of those connectors and how use cases can be leveraged. So take a look there. There's some good resources on that front. Okay, any other questions regarding IoT? Okay, let me maybe present my screen then. So 10 minutes left, and I guess just to maybe share a few other things, and Royston also feel free to chip in. So I think so in the last things have happened in around the community. So last week we also had the MuleSoft partner kickoff. So those who are working for MuleSoft partners, I think hopefully some of you may have attended. There's a few key things that came out of that, I think, and takeaways. And I just highlighted one kind of screen I'd seen, which is, just a recap of all the latest and advancements on the MuleSoft platform in the last kind of, let's say, 3 to 6 months, especially around new connectors, accelerators around healthcare, and on some of the SFDC side of things, Salesforce side. Mesh, which is completely GA, and the updates also into the Mule 4.3 runtime, which has brought, I think, a number of benefits, especially on performance as well. I think probably one of those key advancements as well is also just around MuleSoft Composer. I think for those who are Salesforce customers also. So primarily now from MuleSoft Composer, I guess it's been now embedded, and MuleSoft has been really embedded into the Salesforce platform. I think they previously, I can't remember the name of it now, actually escapes me, but previously they had their own sort of I guess lightweight, let's say, API and integration layer within the platform. I think primarily this has now been replaced also by using MuleSoft, which really kind of points towards this concept of the citizen integrator and being able to connect Salesforce with backend applications without necessarily having to go through developer cycles and alike. I'm not sure how the development partners are going to feel about that, but I think in terms of business productivity and kind of really enabling probably like maybe the business analysts or the product owners and stuff to start generating solutions to the end user. I think it's a really interesting move, and I'm sure we'll see a lot more from in this space over the coming months and for this year and also into next year. And from what I understand, also they're looking to release this as outside of the Salesforce ecosystem as well. So be interesting to really see how that goes. Royston, is there anything else you wanted to add in terms of on the MuleSoft release plan and
for Composer itself, I think you've covered it. I think the best thing to say is watch the space. It's fast moving for the next few months. I did have a couple of other updates around runtimes, but I don't know if you have a slide for that. So
no, you can go for it. Yeah, runtimes.
Okay,
go for it. Yeah.
Just a couple of cursory updates. So for anyone who's still on the 3.9 version, Mule 3.9.5 was released about a month ago. So if you're on Cloud Hub, look into upgrading to 3.9.5. It's going to be the longest supported version for the future. And if REM and you have a reason to make changes to APIs, the runtime 3.9.5 is the best one with the latest bug fixes, but not too many new features. It's mainly a maintenance release. And then the other enhancement is that Runtime Fabric is now GA on GKE. So that's Google Kubernetes engine. And so that means that RTF can now be deployed on effectively 4 different supported variations. So there's bare metal or VMs, or you can use AKS, EKS, or GKE. So they're really the whole, as far as I'm concerned, the whole suite of deployability options available there. So if that's something of interest, it is a little trickier to trial it out. However, if you've got a customer, or if you yourself are a customer who's invested in any of those 3 clouds, you now have options available for you for Runtime Fabric. That's what I wanted to touch upon. There's a lot more, but I think these 2 are interesting to note.
Very good, very good. Next update is just really on certification maintenance. So I think it was announced in the last couple of weeks that, so for those of you who do have your certifications, and specifically from the developer and the architect and integration architect, there's this maintenance option. So without you having to necessarily go through resitting the full exam again once your certification has come into its expiry. So there's a kind of a refresher, let's say, exam that you can really just take just to prove that you still know your stuff, let's say, and this is still valid through, I think, by what I understood, through to the May 31st. But yeah, I've posted the link here, which you may or may be able to see, where you can go out and find more information. Anything, Royston, that you know further about that one?
No, I think with maintenance, you've covered it well. Just on the training part, there is a new course for Anypoint Community Manager Operations. So if anyone's interested in that space, there is a course available for that at the moment.
Very good. So just looking ahead, probably to the next meetup session here in Singapore. So probably targeting around June 24th, TBC. So we kicked off also the session towards the start, and if anybody is interested in presenting, just like we or Senthil today, please do get in contact with us. So I think Royston posted the link. It is on the MuleSoft Meetup website as well. So if you're interested in presenting, if you either go through there, or you can send us direct messages as well via LinkedIn or your preferred channel. Please do get in contact, and we can certainly entertain any topics. So whether it's case studies or technical features that similar to what we and Senthil took you through today. Similarly, if you have a specific point of view, I guess we're always keen to hear those. So yeah, please do get in contact, and it'll be good to see, I guess, more speakers from the community. Yes, thank you, Royston, for posting that once again. Appreciate it. So competition time. So we normally have a couple of handouts, and I'll keep it brief for this week. Maybe just change slide again. So yeah, actually I've got one brain teaser. Actually, I've kept it this week, but it's a bit more complex potentially. So if you, and next slide, I'll present what the question is. It's a bit mathematical. So for those of you that way inclined, I'm expecting big things. And also we'll test how well you've been listening to the presentation today. Probably the first 3 answers, let's say, and closest answers as well, we'll pick, and we'll get something shipped to you in some way, shape or form. So if you type your answers into the chat window as well, and let's see how it goes. Here we go. So it's the nearest billion. So we presented Ford predicted the number of IoT devices to be in 2021. And if you multiply that by the latest version of MuleSoft, what is the answer? Silence. Everyone working it out. Wow. There you go. 5. Any more? Any more? There we go. It's a good few answers. So the answer is 150.5 billion. There you go. So it's 35 times 4.3. It's the latest release. So I think there are a good few answers up the top. I think I saw Amit was the first one to get it correct. Well done, Amit. And who else? Let me look down. Srinivas, well done. And Kia too as well. There you go. So there's probably 3 winners. Congratulations. Well done, everyone. Good job. So that is the end. I think we can get a picture. Is that possible? Royston, do you know how to get pictures? On the attendees. How do we, can you do that?
So what else? You should now have the option to camera. And in the meanwhile, stop screen sharing. That would give us more screen space for our photo.
Definitely work. Yeah, there you go.
Great idea. Never done a picture on.
And is there any way to increase the number of people? Oh, it's increasing as we go. There you go.
Yeah, this made it better.
Jarath, you've grown a beard since the last seen you. Can we get any more people on the screen? That's the question.
Looks like
There we go. Okay. The top of the hour. Thank you very much to everybody for joining us today. If you do have any more questions, please do feel free to drop them into the chat box. If not, yeah, hope you have an enjoyable day and evening if you're over in Singapore. And like I said, so the next session will be around mid to late June. So do please keep a lookout, and you'll be automatically messaged as well with updates to the event details. The slides and the video will be published on the meetup page as well, and we'll send out an email which will give you the link to it, so then you can go download the slides and also rerun the video if you want to hear back any of the discussion from today. Okay, thank you everybody, and without keeping you any longer, I wish you, like I said, all a good evening. Take care.
Thank you. Take care.
Bye-bye. Thanks again, and thanks again, Senthil.
Yeah, thanks everyone. Thanks, Julie.
Thanks, everyone. See you next time.